All right, the next example, the point 2, 4 lies on the graph y equals x squared. So here's our original function. 2, 4 lies on that original function. Identify the corresponding point after each set of transformations, then write the new equation after the transformation. So I always want to set up a visual, have an idea of what this looks like. So we're starting with our original graph of y equals x squared. At x equals 2, my y value to that would be 4. So here's my original point at 2, 4. It says a horizontal translation of 3 units to the right has been followed by a vertical translation of 4 units down. So what I want to do is I want to physically move this point or this whole graph 3 units to the right. And if I'm moving the whole graph, that means my point is also going to move that same distance. So I'm going to go 3 units right relates to my x value. So my new point for x would be 2 plus 3, which would be 5. This is my new point. And then 4 units down relates to my y value. So from 4, I want to count 4 units down, and so 4 minus 4 would give me 0. So my new point would be 5, 0. So now I want to relate these p and q values to my transformations. So my original function is y equals x squared. I am going to now, because this has moved, I'm now going to have a p and a q value. My a value is going to stay the same. There has been no stretch on the function. So I'm going to look at my original function. Well, my a value in my original function would be 1. So my a value is going to stay a 1. My p value, well, this has moved 3 units to the right. So my p value would be a positive 3. So when I substitute a positive 3 in here, this is going to stay an x minus 3 squared. My q value went 4 units down. Down would be a negative 4. So my q value becomes a minus 4. And that would be the equation of my function. All right, so moving on to the next question. We're still going to go back to the original each time. So we're not working off of this equation. We're always going to go back to the original. It's like 3 different questions. Okay, so the next question says a vertical stretch followed by reflection in the x-axis. So again, let's draw that original function. When x is 2, my y value is 4. We want to find this new point. So what's happening is that a vertical stretch has occurred. So what you want to imagine is pinching each of these endpoints and physically stretching them vertically by 3. And when the stretch value is a multiplication value, so this is by 3 times. So this point is going to stretch vertically to way up here. So technically the x value is staying the same, but the stretch in my parabola would now look something like this. Okay? And so that stretch factor, what I want to do is I'm going to multiply my y value by my stretch factor, which is 3. So after this first transformation, my new point would be 2, 12. So that becomes that. Now I want to talk about the reflection. So now I'm going to take this new point at 2, 12, which is way up here, and I'm going to reflect it in the x-axis. So I'm going to reflect it to be down here. So now this parabola is opening down with this new point down here. And so what happens is this y value at 12 is now just simply going to become a negative. My x value is still the same. That has not changed. So my new point would be 2, negative 12. Okay? All right, so now let's write our new equation. Well, our original equation started with y equals x squared. I am now going to substitute A, P, and Q values. Well, my A value is my vertical stretch, which would be 3. I physically have not moved this graph left or right, so my P value would be 0. I haven't moved it. And my Q value would be 0. I haven't moved it up or down either. But my reflection, because it's opening down now, my A value needs to be a negative. So technically an x minus 0 is just x. We don't need to include the 0. So my equation would just be negative 3x squared. Okay, and then lastly, question C, a multiplication of the y values by a factor of 1/2, followed by a horizontal translation of 2 units left, then a vertical translation of 4 units up. So again, let's give our sketch of our original function here. Here it is at 2, my x values 4. This is where I'm starting at. So a multiplication of the y values by a factor of 1/2. So that's doing exactly what this is saying. This is like a stretch of 1/2. So I'm going to take my y value, I'm going to multiply it by 1/2, which would then give me 2, 2. So that would be my first transformation. Now I'm going to apply a horizontal translation of 2 units left. So now I'm going to go 2 units left. Would mean my p value would have to be a negative 2 because left is a negative direction. And 4 units up would mean my q value would have to be a positive 4 because up is a positive direction. So if I want to go 2 units left from 2, right, because this relates to my x coordinate, I'm going to subtract 2 from this coordinate, which would be 0. So my new point is going to become 0, comma, and then I want to add 4 to my y value. So I want to go 4 units up from this 2 after it's been stretched. So my new point is going to be at 0, 6. All right, so now let's write our new equation. So y equals a bracket x minus p squared plus q. So I'm first going to apply my stretch factor, which was 1/2. So my a value would be 1/2. My p value is a negative 2. So when I substitute a negative 2 in here, this changes this to become a positive. And then I'm going to have a plus 4. So my equation would be 1/2 x plus 2 all squared plus 4.